welcome to the video notes for lesson 5-7. This is about linear inequalities, day 1. So, the learning targets, these notes, by the way, begin on page 29 in your notes packet. Linear inequalities, day 1. So, the learning targets for this are, I can graph linear inequalities. That's really what we're going to be doing in this lesson. There is also another target. I can write and use linear inequalities when modeling real-world situations. That's really going to be day 2. So day 1, we're going to focus on linear inequalities. Just remember the inequalities that we've dealt with in the past: less than, greater than, less than or equal to, greater than or equal to. Also, just because not equal to is also an inequality, but we won't be seeing or dealing with that at all in this. Okay, so we have our first example, and I want to talk to you about what we're going to be doing with this. So let me move the screen up. So there's a number of steps that we need to do for this process. So we are going to list 4 coordinate pairs that satisfy the equation. Well, we're not really going to do that. We'll start with 1. Alright? So if I plug in x equals 0, alright, so then I get y is greater than or equal to negative 2 times 0 plus 1. Negative 2 times 0 is 0. 0 plus 1. Y is greater than or equal to 1. So I want a number that is greater than 1. So why don't I choose 4? Y equals 4. So the point 0, 4 fits this inequality. So I'm going to put that point on my graph. 0, 4. So 1, 2, 3, 4. This point, oops, sorry, that's 0, 3. This point, 0, 4, is part of the solution of this inequality. Alright, so, first step, step 1, we are going to change the inequality to y equals mx plus b form. So we're going to turn it into an equation. We're going to treat it like an equation. So this y is greater than or equal to negative 2x plus 1. We're going to treat it like y equals negative 2x plus 1. And technically it does, because this is a greater than or equal to. And then what we're going to use is, we're going to use our slope, m, which is negative 2 over 1, and our y-intercept, which is 1, or the point 0, 1. Step 2, we are going to plot points. Now, if you're not good at doing this using the slope and y-intercept, I guess you could build a table, but that's really the hard way. So, my y-intercept is 1, so negative 2 over 1 is down 2 over 1, down 2 over 1, down 2 over 1, or up 2 and left 1, up 2, left 1, up 2, left 1. Okay, now notice I have not connected these yet. Step 3, we've got to decide if this is going to be a solid or a dashed line. Now what does that mean? Well, I just said I'm not connecting these points yet. Because if this was just y is greater than negative 2x, I would not be able to include these points in my solution. But because it's greater than or equal to, I can include these, so that's going to be a solid. So solid, I'm going to underline the solid, because in our inequalities, if the inequality is underlined, it's going to be a solid line. If it's just an inequality and not greater than or equal to, then it would be a dashed line. So, let me show you the difference. If I wanted to, using my line tool, plot these with a dashed line, it would look like this. But because it is equal to, I'm actually going to use a nice solid line, and it goes like that. Alright, so that's step 3. Step 4, we're going to do another check. So you pick a point somewhere. We already know this point here is part of the solution. You can pick another point. How about the point, looks like 1, 1. Okay? So test the point 1, 1 in the inequality. So this is an ISS check because it's inequality. So y is greater than or equal to negative 2x plus 1. So I'll substitute 1 in for y and 1 in for x. I get 1 is greater than or equal to negative 2 plus 1. 1 is greater than or equal to negative 1. That is true. So everything, so now I have 2 points on this side of the line that work. And that comes down, now we're down to our final step. So stating the solution for this inequality is a little different. We are going to shade the region or the part that is the solution. And label the line. So the line, we label this with the inequality. So this is y is greater than or equal to negative 2x plus 1. A lot of times you want to label it right along the line or right at the very end of it because it's hard for me to write on this tool that way. I'm not going to do it. But the part of the inequality that is the solution is this side of it. So everything to the right of this line or above it is a solution. So that is, remember this continues this way. So if I check any of these points over here, they will work in the inequality. Alright? Okay. So we've seen an example. Let's go ahead and look on the next page. So now we're looking at page 30. Our inequality. So we're going to do all our steps, right? We're going to change it to, so the first step is to change it to y equals mx plus b form. I'm actually going to rewrite this down here. I want to hold on, let's start over here. Y is less than 3 over 4x plus 1. Alright, let me scooch this up. Okay. Oh, that's not what I'm looking for. Try again. Y is less than 3 over 4x plus 1. So I'm going to change it to y equals mx plus b form. So y equals 3 over 4x plus 1. Now, either use the slope or y-intercept. So here's step 1. Here's step 2. To find slope and y-intercept to find points, or build a table. You could also substitute this into your graphing calculator and copy the table from there. Remember, B is going to be the point 0, 1. So step 2 is plotting the points. My slope is positive 3 over 4, so I'm going up 3 over 4. 2, 3, 4. I'm going to put a point. 1, 2, 3. 1, 2, 3, 4. And that's all I can do that way, so now I'll go the other way. Down 3 2, 3, and to the left 4, so that's negative, negative, which is positive. Down 3, and over 4, and there's my last point. Now, step 3, solid or dashed. Notice that my inequality is less than. There's no line under it. So it's not a solid line, it's a dashed line. So I'm going to connect these using a dashed line. Like so. Let me try that again. So, same thing for you. Use your ruler, and what I do is, and I know I'm having all sorts of trouble with this, everywhere where I see a point, I kind of put a dashed line. Just make sure you don't connect it all the way. Okay, I need to be able to tell that is a dashed line. Okay, so it is a dashed line because that means any of the points on this line won't work. So if I tested 0, 1, 0 is my x value, so 3 over 4 times 0 plus 1, and 1 is my y value. Is this true? Is 1 less than, well, 3/4 times 0 is 0, 0 plus 1, is 1 less than 1? No, that doesn't work. So, by the way, this is step 4, doing the check. Let me test another one to see. So I'm looking for less than, y to be less than whatever's over here on the right. So let's test another point, like the origin. That's always a great one to test. So if I plug in 0 for y and 0 for x, does this work? 0 times 3/4 is 0, so 0 is less than 1. Is that true? It is. So now I know which direction I need to shade, and that is this way. Shade, shade, shade. Doesn't have to be perfect, although some of you will do it perfect. And then step 5 is shading in the correct part, and then label your graph. So my graph is y is less than 3 over 4x plus 1. Okay, that's about enough for this video. There are 2 more examples on page 31. I'm going to clear this off. I want you to practice and test this on your own. So, there's 2 examples here. For every person that gets it correct, that'll be a point for each problem. For every 2 people that at least try each one, that'll be another point. So you got potential to earn quite a few points with this practice. If you had any trouble, go back and rewatch the video. Good luck, and we will see you in math.